Hello everyone. Our topic is TM rectangular waveguides. Transverse magnetic rectangular waveguides. A waveguide is an electromagnetic field line used in microwave communications, broadcasting, and radar installations. A waveguide consists of a rectangular or cylindrical metal tube or pipe. Waveguides are most often used with horn antennas and dish antennas. A parallel plate waveguides are always finite in width with fringing yields at the edges. Electromagnetic energy will leak through the sides of the guide and create untraceable stray couplings to other circuit systems. Thus, practical waveguides are usually uniform structures of a cross section of the enclosed variety. The simplest of such cross sections, in terms of case, both in analysis and in manufacture, are rectangular and circular waveguides. Today we will discuss about rectangular waveguides. The fields in a rectangular waveguide consist of a number of propagating modes which depends on the electrical dimensions of the waveguide. These modes are broadly classified as either transverse magnetic or transverse electric mode. Transverse electric mode. In transverse electric wave, the wave propagating in a waveguide, the electric field vector is always and entirely perpendicular to the longitudinal axis, that is, the optical axis of the waveguide, but the magnetic field vector may or may not have a longitudinal component. Transverse magnetic mode. In the transverse magnetic mode, electromagnetic wave propagation, the magnetic field is transverse to the direction of propagation. The electric field is not transverse. For the rectangular guides, Maxwell's equations and wave equations are expressed in rectangular coordinates. Assume the variations in the z direction expressed as e raised to minus gamma z, where gamma is equal to alpha plus j beta. Maxwell's equations become dou hz by dou I plus dou gamma hy is equal to j omega epsilon 0 is ex. Dou Ez by dou I plus gamma Ey is equal to minus j omega mu hx. Dou Hz by dou x plus gamma hx equal to minus j omega epsilon 0 Ey. Dou Z plus gamma dou Ez by dou x plus gamma Ex equal to j omega mu hy. Dou Hy by dou x minus dou Hx by dou I is equal to j omega epsilon 0 Ez. Dou Ey by dou x minus dou Ex by dou I is equal to j omega mu hx. Minus j omega mu hz. The wave equations for Ez and Hz are dou square Ez by dou x square plus dou square Ez by dou y square plus gamma raised to minus 2 Ez is equal to minus omega square mu epsilon Ez. Dou square Hz by dou x square plus dou square Hz by dou y square plus gamma raised to minus 2 Hz is equal to minus omega square mu epsilon 0 Hz. Equations 1 can be combined into a form hx is equal to minus gamma by h square dou hz by dou x plus j omega epsilon by h square dou ez by dou y. Hy is equal to minus gamma by h square dou hz by dou y minus j omega epsilon by h square into dou ez by dou x. Ex is equal to minus gamma by h square into dou hz by dou y minus j omega mu 0 by h square into dou hz by dou y. Ey is equal to minus gamma by h square dou ez by dou y plus j omega mu by h square dou hz by dou x, where h is equal to gamma raised to minus 2 plus omega square mu epsilon. The equation gives the relation between the fields within the guide. If Ez and Hz is equal to 0, all the fields within the guide will vanish. For waveguide transmission, there must exist either Ez or Hz component. For a rectangular guide, the boundary conditions are Ex is equal to Ez, that is equal to 0, and y is equal to 0 and y is equal to b. Ey is equal to Ez is equal to 0, at x is equal to 0 and x is equal to a. Transverse magnetic waves in rectangular guides. We have Ez xyz is equal to E0z xy e raised to minus gamma z. Let E0z is equal to xy. Here x is a function of x alone and y is a function of y alone. We have to solve the second order partial differential equation dou square by dou x square plus dou square by dou y square plus h square into E0z xy is equal to 0. Here we have to use the method of variable separation. Substitute equation 4 in equation 1, which gives y d square x by dx square plus x d square y by dy square plus gamma raised to minus 2 xy equal to minus omega square mu epsilon xy. Put h is equal to h square is equal to gamma raised to minus 2 plus omega square mu epsilon. Then the equation becomes y d square x by dx square plus x d square y by dy square plus h square xy is equal to 0. Divide by xy, we get the equation 1 by x d square x by dx square plus h square, that is equal to minus 1 by y d square y by dy square. The equation equates a function of x alone to a function of y alone. Therefore, 1 by x d square x by dx square plus h square is equal to a square. Here we equate with some constant. And 1 by y d square y by dy square is equal to minus a square. The solution of equation 6 is x is equal to c1 cos bx plus c2 sin bx. B square is equal to h square minus a square. The solution of equation 7 is y is equal to c3 cos ay plus c4 sin ay, and E0z is equal to xy, that is equal to c1 c3 cos bx cos ay plus c1 c4 cos bx sin ay plus c2 c3 sin bx cos ay plus c2 c4 sin bx sin ay. E0z is equal to 0 when x is equal to 0, x is equal to a, y is equal to 0 and y is equal to b. If x is equal to 0, then equation 8 becomes E0z is equal to c1 c3 cos ay plus c1 c4 sin ay. For E0z to vanish, c1 must be 0. So, E0z is equal to c2 c3 sin bx cos ay plus c2 c4 sin bx sin ay. When y is equal to 0, then equation 9 becomes E0z is equal to c2 c3 sin bx. For E0z to 0, c1 or c2 is equal to must be equal to 0. Here we assume beta not equal to 0. Put c2 is equal to 0 in equation 9, we get the equation E0z is equal to c2 c4 sin bx sin ay. Apply boundary condition x is equal to a, then E0z is equal to c sin ba sin ay. To vanish all the values of y, assume a not equal to 0 and a is equal to 0. B must be 0. B must have the value b is equal to m pi by a. Here m is equal to 1, 2, 3, etc. If y is equal to b, then E0z is equal to c sin m pi by a x sin ab. To vanish all values of x, a is equal to n pi by b, where n is equal to 1, 2, 3, etc. Therefore, the final expression for E0z becomes E0z is equal to c sin m pi by a x sine n pi by by. Use equation 3 and put gamma is equal to j beta for frequency above cutoff frequency. We get E0z is equal to minus j beta c by h square b cos bx sin ay. E0y is equal to minus j beta c by h square a sin bx cos ay. H0x is equal to j omega epsilon c h square by h square into a sin bx cos ay. H0y is equal to minus j omega epsilon 0 c h square by h square b cos theta bx sin ay, where b is equal to m pi by a and a is equal to n pi by b, where a and b are the width and height of the guide and m and n are integers. Also, a square plus b square is equal to h square is equal to gamma raised to minus 2 plus omega square mu epsilon 0. Therefore, r is equal to root of h square minus omega square mu epsilon, that is equal to root of a square plus b square minus omega square mu epsilon 0. Here we get the final equation gamma is equal to root of m pi by a the whole square plus n pi by b the whole square minus omega square mu epsilon, where gamma is the propagation constant for a rectangular guide for TM wave. For low frequencies, omega square mu epsilon is very small. Gamma will be real number. If gamma is real number, b must be 0. Now phase shift along the tube. If the frequency is increased, omega will be greater than omega c. Then beta is equal to root of omega square mu epsilon minus m pi by a the whole square minus n pi by b the whole square. If omega and also omega c is equal to 1 by root of mu epsilon root of m pi by a the whole square plus n pi by b the whole square. Here we get the equation for cutoff frequency fc is equal to 1 by 2 by root of mu epsilon into root of m pi by a the whole square plus n pi by b the whole square. The cutoff wavelength lambda c is equal to 2 pi root of m by a the whole square plus n pi b the whole square. So, fc into lambda c is equal to v0. The velocity of wave propagation is given by v is equal to omega by b, that is equal to omega by root of omega square mu epsilon minus m pi by a the whole square minus n pi b the whole square. The wavelength of the guide is lambda is equal to 2 pi by root of omega square mu epsilon minus m pi by a the whole square minus n pi b the whole square.